Hello.
Can you hear me?
Yes. All right.
Okay,
Apologies for
good.
being late.
No, that's okay. That's okay. Too many things, you know. Yeah. Okay. Right. So start the next phase. All right. This is the phase which is much more probably important to you because of what you are doing. Okay. So also it forms the basis of the things you are more interested in. Okay. Right. Okay. So we're going to look at this now. Some of the things I'll be explaining beyond these basic levels. Okay. As I continue. Where's my pen? Yeah, here it is. Okay. So I'm not just looking at what you're doing now because this is just to get you the basics you need. So I may contradict some of the things that are there because that's not the way to treat them, but it's just to make life easier. Okay. Yeah. Right. Okay. So we're going to look at what is called line graph. Okay. So line graph is one way of presenting the results of your research or survey or your analysis. If you're going to do the case study analysis, you extract the data and then you analyze it and then you present it. Okay, so this is another way of presenting the results of your research. Okay, not presenting data. Data has no meaning. So here, when you hear data, it sounds as if data is information. No, there's a big difference between data and information. Information has a meaning. Yeah, data hasn't got a meaning at all. So when you are interviewing people, yeah, what you are collecting is data, not information. No. Okay. Right. Okay. So let's look at what these are. So they're going to be they are talking of line graph. There are different way of presenting things. These results visually. We call it visually, so you can see. Yeah. But most when you look at the book you are looking at, you see two different ways of presenting data. One is going to be graphs, and the other one is going to be the texts. Okay. Now, why? Because we have four different ways of learning things or understanding things. We are all different. There's no one which is actually superior. Okay. So others, they can see the graph, yeah, visually, and they'll be able to grasp whatever is written there quickly. Others, they would prefer to read the text. Okay. Others prefer both of them. Okay. Others prefer touching, experiencing, rather than reading about it. All right. So we are all completely different. Yeah. Okay. We are all completely different. But there's no superior. No. It's just the way we are made. Right. So in terms of graphs, there are going to be different types of graphs. Okay. We are going to have pie charts, histogram, bar charts. Okay. But this one here, okay, is going to be called line. Now, in your book, it's going to be called the linear graphs. Because so when we learn mathematically, it's going to be called linear graph. A linear graph is exactly the same. What it means is the graph of a straight line. That's all. Okay. So the difference in your maths, which is your red book, is that it is looking at a straight line, while here line graphs can bend. Actually, you can see increase, you can see downwards, you can see upwards, you can see, it fluctuates depending what actually you are showing. Okay, that's the difference. So that's why I just calls it line graph, or it means it's a linear, it's a line. Okay. Right. Okay. So let's look at what he's saying here. All right. So it's talking about it. Okay. Handling data. Yeah. Okay. As I say, I would differ because he's talking about it. Data is information. You can see right away from the beginning. Yeah. It's already made a mistake. No, data is not information. No. Okay. It's the information that comes after you've analyzed it. Yeah. As I said last time, two has no meaning to you at all. Okay, until I said two boys or two chickens, you can see, and I've analyzed. I've attached the two to chicken or to people. Yeah, so therefore it will have a meaning to you. Yeah, I'm sure if I say two boys, you automatically know I don't mean two chickens. No. Okay.
I think
Right. So
another word for data in this case is intelligence.
Intelligence, yes, intelligence, because it's a collection of
raw.
facts. Yeah.
Raw.
Yeah, it's the raw. Yes, it's a fact. The facts, they need to be analyzed. You can't just present them as they are. Okay. Yeah. And also remember that data, you can actually manipulate it to suit the situation which you are actually looking at. In most cases, when we do what we call literature review, we are looking at the secondary data that was collected specifically for a certain research, but you are going to analyze it so it fits what you want to do. So that's why if you're going to analyze the same data, it's going to give you a different meaning altogether. Okay.
Okay.
Yeah. Yeah. So as you're saying, data is information. Information reaches us in many ways. Okay, so in words, okay, where obviously it can be written words or can be spoken words. Okay, in numbers. Okay, so or in pictures and also in diagrams. Okay? So diagrams are a way of presenting information in a visual way that is easy to understand. That statement you see is exactly what I keep on saying. I look stupid because most of the time I tell someone this is very easy, you know. It's not easy to understand. No, because we are all different. All right.
Yes.
We are all different. So, so the some of these things probably after you have published the book, that's when now you say, no, I made a mistake here. Okay, but too late, you can't correct them. Okay, so line graphs as well as the pie charts and the bar charts present the statistical information. Okay? Now, statistics is a numerical information, so it's a quantitative, and it is often much easier to see the information on a chart or a graph than as a list of figures. As I said, some people would prefer both text and the graph. Okay. Right, so let's look at this here, okay, line graph, all right? So what most important things here that we need to look at, okay? Now, in your problem, you're going to be drawing this. You're not going to have this already made, all right? So what is it that is important? Right, so the first, what you see there, okay, you see a vertical line, okay, and you see a horizontal line. This is freezing. Oh God, yeah. So you see a vertical line and a horizontal line. Now, in your normal graph, okay, what you will have, I'll go to the board. Okay. Okay. So in normal, your graph, what you see is this line and this line. Okay. So this line is called the x-axis, and this line is called the y-axis. All right. So what happens here? We use almost 99%. We tend to use only this quadrant here. Yeah, this one. So this is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. Okay. So in most of the graph, we take this first quadrant. Okay? Because in this first quadrant, y is positive and x is positive. While in here, x is negative, y is positive. In here, okay, you will see as we go down here. So if you look at here, this is positive and this is negative. While in here, both are negative. This is negative, this is negative. If you don't understand, say, I can't remember. Okay.
No, my problem is that I can't see the writing if you're writing.
So I can't see the. Oh God.
No, wait. I'm not sure if the writing. Try writing something. I can't see your cursor. So if you were pointing, if you were just pointing, if you could label.
Let me try with the Let me try with a different color.
Okay. Yeah.
Can you see the color? Can you see color? Yeah. Okay. So let me remove and start again.
Okay.
Yeah. Yeah, because it's important. It's very, very important. It's
and if you could label which is positive and negative is better.
Yeah, that's what I want to do. That's why I was saying when I'm saying something, make sure I say no, I can't remember those. Yeah. Don't just say yeah. No. Yeah, you become a yes man. Yeah. Okay, can you see this red? Yeah. So
yes.
This is Y. Okay, this is X. So this is called X-axis, and this is called Y-axis. At the point here is 0. So this is 0. And as you go to the right, this is going to be positive. 1, 2, 3. If you go this way, it's going to be -1, -2, -3. The same way, if you go up, it's going to be +1, +2, +3. If you go down here, it's going to be -1, -2, okay, -3. Okay.
So the x-axis, is it always horizontal?
Yes, go on.
And the y-axis is always vertical.
Yes, yes. Y-axis is always vertical. Now, when we'll be going deeper, it's called dependent variable. It depends on x. So its value will depend on the x. What it means is that if x changes, y is going to change. Okay. Right. Yeah. So what I'm saying, 99% we're going to be in this quadrant here. So this is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. Okay. So in quadrant 1, both x and y, they are positive. In quadrant 2, y is positive, but x is negative. In quadrant 3, both x and y, they are negative. While in quadrant 4, y is negative, but x is positive. Okay, so in most of the cases, the graph you see is going to be looking like that. So you're only using this bit here. That's all. Okay. Yeah. Okay. So let's go on. So that's the first thing you need to notice there. Okay. Yeah. So we are using this quadrant. If you wanted, you would have continued here, and then you would have another line there. Okay. Right. Yeah. So there are things here we need to know and understand what they are. Okay. So the first, right? I said the vertical axis is y-axis, and it has got dependent variable. Its value is dependent on the x-axis. X-axis is called independent variable. Each value doesn't depend on any of the y value.
Y-axis is a variable.
Is dependent. Dependent. Right. Yeah, it's depending on the x. So its value is going to change if you change the value of x. But x is going to change without changing the value of y. Yeah, this is extremely important to understand because that's what is going to create a problem when you try to draw the graph. So there's a lot of thinking going in it, okay, which means if immediately whatever you are drawing about, the graph about, you need to understand what is the x-axis, what is y-axis. In a sense, what is the independent variable, what is dependent variable. Okay. The next is the scale. Okay, so you need to know the scale. Now, these scales are determined by you. The smaller the scale, the more crowded the graph becomes, the poorer the vision will be. Now, it's going to be the scale for y-axis and the scale for x-axis. Sometimes you may have the same scale. Sometimes you may have different scale. So the scale is just what is the difference of, for example, you can see here, from here to here, yeah, is going to be 100 take away 80. Okay, so 100 take away 80 is 20. So half of this is going to be 10. And that's why this is 90. So sometimes you may not have this. They have just given you 100, 120, 140. Yeah, but you need to determine this scale here. Yeah, yes. If they are smaller segments, you need to work out what each one is, because working out the value might be difficult if you don't understand that scale. That also will apply, yeah, horizontally. Okay, as I say, sometimes the scale here is different from the scale here. Yeah, most of the students, what happens, they think if the scale is the same, so they get the whole question wrong. Right. Number two is going to be the label, right, which is very common to you who writes the assignment projects or assignment actually. So labels are extremely important. Now, these are labels. So we know what is in the vertical axis is height. And we know, okay, what is in the x-axis is age. So these are called labels. So in your graph, you need to make clear what these labels are. There's also a label here, which is is missing. Okay, but he has put it in up there. Should not be there. It should be down here. Okay, so this one here. Okay, so yeah, this label would have been here. So it would have been a figure, okay, or table 1, and then obviously it's showing. So what this graph is showing. Yeah, so showing it, the ages from 2 to 18, or changes in the height as the age is increasing. Okay, so now generally, right, the graph, as you can see here, as the age is increasing, the height is increasing, and that's what we expect. So we expect if the child is growing, the height needs to increase. If the age of the child is increasing and this is not increasing, then it means the child is stunted. So therefore, there's a problem, and that's how we identify that the child has a problem. In fact, the first person will come, he say, I hear the mom says, look, my child is not growing. Okay, he's 2 years now, but his height is only this. They know exactly 1 year child how much height you need to have. Okay, right. So you can see, all right, if I change the age, I expect to change the height. So the height of the child is dependent on the age, but the age can change without the standard changing. No, as I said, in a stunted growth, it will mean the age will be greater, but the height will be lower. Sure, this one is independent because it can change on its own. This one is dependent, is depending on the age itself.
Okay? So the y-axis here is time. Is it? Is there a rule? Is there a rule that the x-axis being always time?
No, not always. No, because you're going to measure other things. Is you need to assess yourself. You need to understand what is a dependent variable here, what is independent variable. Okay. So what you are looking here is also called the relationship. Okay. So relationship between the age and the height of a child. All right. So again, we're going to do at one point we're going to be talking about this relationship in maths. In statistics, you're going to talk about correlation, regression, not yet, a long way to go. Yeah, but basically, when we are going to learn about basic maths, we're going to talk about the inverse relationship and direct relationship. So this is a direct relationship. Okay, as the age is increasing, the height of the child increases. So this is a direct relationship. Yeah?
Yes.
Okay, right. So as it says, this graph shows a fairly steady increase in the height. We can see that between the years, so we're looking at year 2. Okay, also one thing, it shouldn't always start from 0. Okay, that's what you notice here. This one is starting from 0, from 1 for the vertical axis, so this one. But this one here, you can see, is not starting from 0. It's starting from, this is 80, and this is 70. Yeah? So it doesn't necessarily need to start from 0. No. Okay. Right. Okay. So what you can see, right? So from age 2, okay, up to age 18, the height has increased from 90 to 180. Right. So they can ask you, what's the percentage increase in the height here? How do you work it out? now that you have done your percentages?
Yes. Well, you'd need for each new. Well, you could start. Where would you start? Would you start at 70?
No, look at the age. So they're asking you the age, the height,
fine.
The percentage in the increase in the height. What numbers? Everything is there.
Yeah, I think the first one would be the difference between age 4 and 2. So I would put.
It's over this period from 2 years to 18 years. They are asking you what has been the percentage increase in the height of this child from 2 years to 18 years.
Oh, all right. So 180 over 90. No, I'm sorry. 180 minus 90 divided by 90 times 100.
Yeah, that's the percentage increase in the height.
Whole,
yeah.
All right.
Okay. So if we're going to look at the, let's say for example, okay. So we can look at the year 10. We can look at the year 14. When you look at year 16, when you look at year 18, we should be able to tell, what's the heights are. So we can actually read off from. So for example, we know here, so all we need is take a line down. And then also look at this line here. Okay. Yeah, so it corresponds. So it corresponds the age with the height. All right. Okay. All right. Let's move on.